All right. Hello, everyone. Welcome to this week's episode of Pulumi TV. My name is Luke Hoban, CTO at Pulumi, and I'm really excited to be back again this week to talk about serverless with Pulumi. So last week, if you joined us, we kind of talked about Kubernetes and a bunch of the new things we've done to support Kubernetes and make that a really great experience within Pulumi. But as we talked about, Pulumi really kind of allows you to do a variety of different tasks in terms of managing cloud infrastructure. So as well as doing managing your Kubernetes resources, you can also manage raw cloud infrastructure in AWS or Azure or GCP. You can also do serverless and containers directly against these platforms. And so today, kind of wanted to go and do a deep dive in the serverless part and show some of the new things we've done, show some of the things that you can do using Pulumi in terms of deploying serverless applications. Now, one thing to note is, that's really interesting, I think, here is although a lot of developers are doing just Kubernetes or just serverless or just infrastructure, one of the things we increasingly find when we kind of go and talk to folks is that people are doing a combination of these three. So they're really combining in the same application, doing Kubernetes plus infrastructure or infrastructure plus serverless. And it's these combinations where Pulumi can be really powerful and really open up new possibilities for how you think about developing and deploying your applications. So today I'll really do that dive on serverless, but one of the key things to keep in mind for Pulumi is that you can combine all the things I'm showing today with the kind of things we've talked about around infrastructure and Kubernetes and other things in the past. So with that, let me dive straight in and I'll kind of do a tour through kind of getting started from nothing to kind of some working serverless apps and show some of the building blocks of how you can inject serverless features into your cloud native applications with Pulumi. Okay, so here I am on the Pulumi homepage. And you can see, as we kind of talked about, the areas that we focus on in terms of serverless infrastructure and Kubernetes. One thing I just noticed, we just hit 1,400 stars, so thanks everyone who's gone out there and been participating in the GitHub project. Pulumi is open source, and so we've had a bunch of folks jumping in, sending contributions, opening up bugs and issues in the bug tracker there. So really having fun with the community that's building up around the open source project. But to get started, I'm going to go ahead and click sign in here, and this takes me into the Pulumi portal. In this Pulumi portal, I can sort of manage my my Pulumi applications. And so one of the things we recently added was actually the ability to create a new project directly from inside this portal. So previously, you could go and create a new project from the Pulumi CLI, but we didn't have an entry point here to sort of walk you through that process. And so now we do, and this makes it really easy to kind of get started with Pulumi. And so for today, I'm going to focus on AWS, and I'm going to use TypeScript. Pulumi, of course, supports a variety of different platforms: AWS, Azure, GCP, Kubernetes, OpenStack. We recently added vSphere support for VMware, and also a variety of languages, so TypeScript, JavaScript, Python, and Go. And there's a recent community contribution to add .NET, and we're continuing to add those as well. Today, I'm going to start just with this AWS TypeScript example, and I'm going to create it in my account. Just use this simple name here. Well, let me just call it serverless, since that's what we're talking about. And I'm going to do it in US West 2, and I'll just create project. So this has gone ahead and created the project for me and just given me the command I can type here to go ahead and create that. So first I'm going to create a demo today, and then I'll just paste that command in to go ahead and create that project. And this will actually bring down the source code of one of our templates, and then ask me for any information I need. Since I put that in on the website, I don't need to provide any. It'll go ahead and preview what's going to happen when I deploy this application. In this case, the template just deploys an S3 bucket. I go ahead and say yes to accept that, and we'll actually deploy that directly into AWS. Okay, so there we go. We have our first Pulumi application deployed right there. So I'm going to open up this folder and just see kind of what we've got in this application. So the core of it is just this simple index.ts file that we see here. We've got a bucket, and that bucket has, and then we expose the bucket's domain name out here. And you see that over here. When we stood up this stack, we got this bucket name called this. Okay, so we've got a very simple piece of infrastructure that's deployed that's just creating a bucket that I'm going to manage with my Pulumi application. And so when we think about serverless applications, we often think about sort of the ability to have little pieces of code that we can write that are run in a serverless fashion. We don't have to deploy a heavyweight VM or container. We can just say, here's some code, run this on these events that might happen inside my infrastructure. And these kind of serverless patterns can be tied to building full sort of API gateways, and we'll show some examples of that later. But frequently, they're actually tied just to pieces of my infrastructure. And so in this example, for instance, I have this bucket, and I might want to do something on an event. So when a new object is added to that bucket, I might want to do something. So one thing I'm going to do is, for the demos today, I'm actually going to use some new features that we've recently added in that aren't yet available. And so what I'm going to do is use the dev package instead of the latest package. And this will pull in the not yet released version of this. All the demos I'm going to show today are available to use on top of some of the released packages as well, using some libraries like the AWS Serverless library. We're actually moving to make a lot of this more first class, and so I'm going to show that experience today using the very latest packages. So now that I have that, I'm just going to run npm install to update my dependency to that latest package. And since Pulumi is using just regular npm packages to deploy these things, I am just able to say dev and use the npm toolchain to go and get that latest package and update it. And now my system is using the latest packages with the latest features. And among them is the ability to say bucket.onEvent or onObjectCreated or onObject removed. And so these are new APIs that we've added that give you the ability to hook up event handlers when something happens in this piece of infrastructure. And so, for example, when this bucket that I created gets a new object created, I'll just call this new object, now I can run a handler. And so for this example, I'll say, let me just write it like this. So what I want to do here is say when an object is created on this bucket, I want to handle it with this event. And so let me just go ahead and write console.log ev, console.log ctx. So one of the things you'll notice here is when I hover over these, because I'm using TypeScript here, I actually get sort of a lot of the information inside my editor. And this is one of the really nice things about using Pulumi to define my infrastructure and to define my sort of these serverless handlers, is that I get all the sort of typing information, I get the error handling, that sort of thing from a real programming language. And so here, for example, I get told that this event is actually going to be a bucket event. So because this is an event handler on a bucket, I'm going to get back a strongly typed bucket event. And so I can actually see what that's made up of. We can see this is the details inside there. I can get the bucket and the object that was impacted, that sort of thing. But for now, I'm just going to print it out. And similarly, this CTX is a well-defined object that AWS Lambda has, that is the context that the Lambda is executing within. So I'm just going to print both of those out to the console. And the nice thing is here that I'm kind of combining the ability to create and manage my infrastructure, this bucket, along with the ability to define some code that's going to run when things happen with my infrastructure. Being able to define these in one place and version them together is a really nice capability, especially for kind of building serverless applications. So let me come over here and just say Pulumi update. Pulumi update, and I'm just going to say Pulumi updash. Pulumi updash y. I'm just going to say this to go ahead and accept the update. Pick that same stack that I just deployed, and this will show us first a preview of what changes this is going to make, and then it'll go ahead and apply those changes because I said -y. And so we see a couple of things. First off, we're creating this bucket event subscription, which has a function associated with it and some roles and permissions to assign to that function. And then second, we're attaching to this bucket a bucket notification. So we're saying that we want that bucket to be notified whenever that changes. So this is go ahead and deploying those resources to AWS. Oh, and there we go. It just finished a second ago. So it took about 22 seconds to deploy that, and we created several different resources. So there's a couple of nice things here. One, I'm using a slightly higher level pattern for doing this. I don't have to think about all the different details about how I create the bucket subscription objects and how I create the permissions for the Lambda and how I create the AWS Lambda object itself. Doing that, raw against the AWS APIs is possible, but it's a fair bit of boilerplate that you kind of have to do every time. And so here we're giving you a really simple way to hook those up in sort of the canonical way. If you need to hook them up and control every detail, you can of course fall through to the underlying APIs. But the result is that with just a couple lines of code, I can sort of create the various resources I need in AWS to handle this. And so now I can do something like AWS S3 ls S3 : let me just say. Actually, first I'm going to do one thing. I'm going to make my default stack be this one that I I created. So Pulumi has a notion of stack, so I can have multiple instances of my application that are stood up at once. In this case, I'm just working with one instance of this application, and it's this one that I created in US West 2. So I'm going to pick that one, and now I'll just say AWS S3LS, Pulumi Stack output. Let's grab the name of this bucket name. So this will make sure that whatever the name of my bucket is, I just insert right in here. Now there should be no objects. Sorry, I'm exporting the DNS name of that bucket, which is not the right thing to use for this. So let me just do a quick Pulumi up-y to export the bucket name itself. So we don't have to make any actual changes to our infrastructure, but we see now that the export is not this DNS name, but the actual bucket name. And so now let me just try that one more time. Okay, great. So there's no objects in my bucket right now. But let me put some object in there. So I'm going to take the package.json file that's right here, and I'm going to put that in that same location. Okay, so this is taking that bucket that we just created using Pulumi and putting a file up into the bucket manually. And what this should do is actually trigger that event that we saw, that onObjectCreated event. And so to see whether that's created, there's kind of a couple ways I could do that. So the first, and I'll sort of show the more involved way first, is to come over here and look at the details of my my application inside the Pulumi console. And so the Pulumi console kind of gives me the whole history of what the deployments I've done, of the outputs of the stack, including this bucket name here. But importantly, it then also has this resources tab where I can drill down and sort of find all the details of these resources. And in particular, I can see this lambda function and click on this and come over into my AWS console. And so here I can go to monitoring, and I can see that this was actually hit once. So that means that this function I created was actually triggered when I plugged that in. And if I come over to view the CloudWatch logs, I can actually see the logs that I just ran. So that's one way I can do this. But Pulumi actually also has built in a really handy command, Pulumi logs. I'll just do logs-f to follow the logs. And what this does is shows me that same information, but directly from the Pulumi CLI. And so because I deployed this application with Pulumi, we know what all the different resources inside it are, and we can provide an aggregated logs over all those resources. And so this shows that same thing. It shows the two things I console logged, the event and the context object. And so here, here's that event object. Obviously, there's some inner structure that we didn't print out here. And here's the context object with all the details of my my Lambda execution context. So here we go. We've just deployed a really simple serverless application to AWS using these really nice built-ins like onObjectCreated. Of course, we can go a lot further here if we want, right? So we can do things like inside here, we could go and use the AWS SDK, and we could use that to get the contents of that object and do something with it. We can also, of course, because we're we have full access to everything in AWS, we could do something like create a new aws.dynamodb.table, and I won't fill in the details of this right now, but we could create a DynamoDB table, and then inside this event handler, we could put information about that into Dynamo. We could create a Aurora serverless table or instance and use that from within our serverless function here. So the ability to combine all of the infrastructure in AWS with the serverless functionality, really handy way to kind of combine the best of infrastructure with the best of these serverless things. Okay, so in this example, I did this by just writing a little event handler right in line here in JavaScript. But you may sort of have a couple of questions here. One is, what if I want to control some of the characteristics of how this piece of code runs? So maybe I want to run with more memory, or I want to run with a particular IAM role that is very specifically tailored to my organization or the needs of this application. And so what we can also do here is we can create these sort of Lambda functions in a more explicit way. So I can say something like new aws.lambda.function. And there's actually two kinds of functions that we now support. So we support Lambda function, which is the full capabilities of the underlying AWS Lambda API. So the ability to wrap up any other language zip file and upload it and use that as my function. But if I still want to use this capability to provide a little callback in line, I can use this callback function override. So I'll just call this F. And you see there's a few things here. So one, I can provide my callback. And so I can just take the same callback I had down here. And in here, instead of me passing that callback directly, I can pass this f, which is my callback function. The benefit of this, of course, is that now I can do things like, say, memory size 2048, right? So maybe I want this thing to be a much bigger memory size. By default, if you looked at what we printed out over here, by default, this was using a 128 megabyte instance, so very small, not much compute. This may not work for my needs. So I can just write it like this to override the memory size, and now I can pass that object in here. And so now I can do Pulumi up-y. And we'll see that this will actually propose a set of changes to my application. And so a variety of different things. A, we're going to create some of these new roles and functions. B, we're going to delete some of the old ones. And then we're actually going to replace the permission that gives this new lambda access to my function. And so Pulumi figures out all the changes that it needs to make to the infrastructure in the most minimal way. And it'll just go ahead and make those changes. So you see some of these things are created, some of these things are being replaced, and everything else is being updated. Once those changes are made, my application is now in this new form, and if I go ahead and copy this thing in there again, I can type Pulumi logs-f, and we should see now another event in my stream. Might take a second for this to show up because we got to warm up a new lambda. There we go. Okay, so that time we saw. It took a second, it took a little while to run that. Actually, it says it only took 16.83 milliseconds, but it felt like it took a little longer. Maybe that was just CloudWatch taking a while to get the logs. But we'll see that this time when we ran, it was 2048 megabytes. So we actually ran with that new context that we provided within the callback function. Okay, so this is a really nice way to just fully control the context. So I could also pass the role that I want to use and manually create an IAM role. If I want to just define the policies, I can say, hey, I want the aws.im. Maybe AWS Lambda DynamoDB execution role, or I could define my own. So I can use any existing policies that I want or create my own policies. And there's a whole bunch of other properties that are available here. If I want to set up the dead letter configuration, if I want to set up the KMS key to encrypt my environment, anything I want like that, I can go ahead and do from these. As we mentioned, of course, I could, if I want, actually use the AWS Lambda function, and then I can provide the code, and I can just, if I have an existing, Python application that I want to host inside this function, I can do that by just pointing at the location of that folder and zipping that up and sending that up to Lambda. So the full capabilities of just taking existing serverless kind of apps that support Lambda and deploying them this way and hooking them up to events using functions like this is also all available as well. One other kind of nice thing that we added recently that helps with a few different patterns we've seen folks using kind of some of these serverless capabilities with is actually the ability to specify not just a callback, but a callback factory. And so a callback factory is just effectively a function which looks like this. So I just wrap that event handler that I wanted, that just prints out the results of the event in context. I just wrap that in a function which is called and then returns the inner handler. And the key thing is this gives me a chance to put some code that runs before the actual function is returned. And so this is really handy because in most of the serverless platforms today, when they run your functions for you, they'll actually stand up an instance of your function and keep it warm for a period of time. And then they'll invoke that function, that same instance of the function, multiple times every time a new request comes along. And so as well as having access to what runs when that function gets called, you sometimes want to be able to control the code you run once per warmup. And so this may be code like, hey, printing out some context about the instance and when that warmed up. It may also be something like, connect to my SQL database, and then maybe inside my handler I want to actually make a SQL query. And the cost of connecting that SQL database may be non-trivially high, and so I want to do that only once per instance of my function that gets warmed up, not every time a new request comes in. And so for high performance kind of applications of serverless infrastructure, this is super important, and we now support that directly using this kind of callback factory mechanism. So I'll just to show this, I'll do the same thing. Pulumi up-y. go ahead and deploy that new function. So we changed the code a little bit. Now if I copy that thing in again and look at my logs, this time you see I actually got this message saying warming up. And so it does a warming up once, and then we will not say that we get run again every time the function gets called. So it looks like the function is being called right now. We got run once. If I come over here and copy that in again, we actually see now we've got two of these. There's the warming up there. And then there's one instance of it running, and we're about to see the other instance of it running get logged in just a second. Okay, there we go. So it just finished running. Okay, so there we see we can kind of also do this pattern of kind of doing warm-up tasks as well, and completely control what gets run as part of the lambda function. Okay, so one of the key things here, I've talked a lot about kind of this on-object created on buckets, but we really support sort of a wide variety of this sort of thing. So there's many patterns that we can support here. So like aws.cloudwatch has a CloudWatch events. So I can say on schedule, for instance, and I can say, every minute. And then I can pass a pattern, and so I can pass a pattern like this. And now I can just write a little function, and again, this function will actually get run every time, every minute. And so again, we see this is actually a AWS CloudWatch event target, so we can get the details of when that was run, the time that it was executed, and that sort of thing. But this is another example where I can just hook up into my infrastructure something like something to kick off a task every minute or every night or anything like that. Similarly, we can do things with sort of API gateway. And so another really popular use of sort of serverless is to create simple REST APIs that we want to support that are tied into our infrastructure in some way. Maybe they give us access into or a front end over some containers that are running in our, or some VMs that are running inside our backend systems. And so in the same program that deploys my VMs or my containers, I might want to just create a simple little API that maybe is exposed only through sort of a management endpoint. And so I can do something like let API equals new AWS dot, in this sense, we'll put it under API gateway. This one's actually in a new sort of experimental namespace because we're still kind of working on the design of this. But I'll show kind of what this looks like. And what I can do here is I can specify a few things, the main one being route. So I could actually specify a Swagger string, and this would just let me take the existing Swagger specification of AWS API Gateway and automatically create an API for me that's managed. I don't have to think about all the different deployments and stages and all these different things. But I can make it even simpler and just do something like routes. I can specify a set of routes. So here I'm going to say my path is on the route, my method is get, and my handler is, oops, let's do it like that. And maybe here I'll say turn status code 200, body, hello world. Okay. So what this will do is it'll actually create a handler which takes an event, and again, this is an API gateway .x.request. So this is the pattern that the API gateway will pass as a typed object. And API gateway expects me to pass back something with a status code and a body, indicating what the HTTP response should be. So now I can create that, and I can just come down here and say export const endpoint equals API.url. And so this should expose a new REST API that on the root of its API will serve, if I make a get to the root of its API, I'll get back 200 and hello world. And so let me just come over here and do my same Pulumi up-y. Okay, so this is actually going to create several things. And this is, again, another example where I can write some very simple code that kind of makes sense in terms of what I want to do. And I can get back sort of the reasonably complicated set of AWS primitives that I need to make that really happen. And so in this case, that's a few things. I need to create this API gateway REST API, this deployment, this stage. I need to give the Lambda permission to be invoked by that API gateway. And I need to create that default role. So we go ahead and can create all those things. It's very fast to create these resources, but there's a lot of different resources I've got to stitch together in a very particular way. And so all of that is what we've wrapped up behind this little helper API. And we see now that we have this, this endpoint here, and if I hit that, you'll see that I actually get back this hello world. And so we actually were able to successfully deploy that API and run that code. So one other thing to note about these kind of little callbacks is, and I haven't really emphasized this here, is that I can, of course, inside these APIs here, I can write any code I want to use functionality of my infrastructure. And so in this example, I have this bucket that I created. And what I could do here is, instead of just saying hello world, I could say something like hello, and then I could say bucket.id.get. And so I want to get the ID of that bucket and embed it in here as a string. So what that's going to do is it's going to have my API now tell me where that bucket is. And so actually I'll just put a s3:/ in front of it. And if I come over here and just deploy that, we'll see that all we're going to need to do is update the actual function that was deployed into this infrastructure. So it's very quick to update that. It only takes a couple of seconds. And now if I come over here and hit this endpoint again, we'll see hello, and now we have my S3 bucket. And so this is really valuable because I've actually had in the same piece of code where I'm versioning both the bucket and the API I'm defining, I have access to that as information, and so I can embed in here anything like that. I could also, write new objects into that bucket as part of this API. I could, when an event happens on that bucket, I could trigger putting something in DynamoDB or in my SQL database. I can sort of hook all these things together using these little pieces of serverless functionality. So there's quite a few more of these. Pretty much every place where AWS exposes some event handler, some capability to run a lambda as a result of one of these things, we have the ability inside the AWS APIs now to write these very simple callbacks that hook up to that and make it really easy to add some of this rich functionality into your cloud infrastructure. So I've really focused in this demo so far on kind of some of the primitive building blocks we have available, both in Pulumi to kind of use these callback functions, that sort of thing, and in AWS specifically to hook up some of those event handlers. And those are both really important building blocks, but there's two key additional things that are worth calling out. The first is that we kind of support the same functionality for all the cloud providers. So if you're on Azure, we also have similar functionality, and we're working on adding even more of these event handler hooks into Azure. On GCP, we have the ability to kind of create wrappers over functions and do things like this as well. So over time, we're going to be adding the same level of richness you see here across all those platforms. So that if you're using GCP, Azure, AWS, or even if you're doing kind of serverless things on Kubernetes, that you have access to these same kind of simplicity of API in all of those places. The second thing, though, is for many users, they actually want to go kind of a step further and think about how to build these sort of applications in more of a cross-cloud way. So how do I take, instead of me having to specify this is in terms of API gateway, can I specify this in terms of just, hey, I have this Express application that I want to run in the cloud, and I want to describe how that's going to run in a way that I could deploy to AWS or to Azure or to GCP or somewhere else. And so one of the things we've done in one of our packages called Cloud Package is really enable that kind of scenario. And so I wanted to quickly show that just as an example of how we can take some of these patterns and move them to kind of multi-cloud. So to do that, I'm actually going to use an additional package. So I'm going to say npm install -save, and I'm going to say @pulumi cloud and @pulumi cloud AWS, because I'm going to be using this cloud package to target AWS. While I'm at it, I'm also going to install Express and types Express, because I'm going to use that in my demo. Okay, so now I've got all of those. I can come over here and say, I'm just going to actually delete all of this stuff. And while I'm doing that, I'll say Pulumi destroy or Pulumi up -y to remove all that existing stuff from this application. Okay, and we'll let those all delete in the background, and we'll come over here and just write a little bit of new code using this new package. So in this Pulumi Cloud package, we give you access to some similar building blocks, but these building blocks are not tied to any particular cloud platform. And so I can say something like new cloud dot, and I get access to some higher level concepts. So cloud.table, which is a NoSQL data store that can map to something like DynamoDB on AWS, but also can map to something like Azure Table Storage on Azure. And similarly, a bunch of other things, buckets, HTTP endpoints, etc. So the one I'm going to highlight today is actually the ability to say new cloud.http server. And so when we showed the example of kind of exposing an API in the previous example, that was really specific to API gateway. And the objects we got passed, the event and context objects were the API gateway ones. And those are obviously going to be different on every different cloud platform. And for most users, they don't really want to think about those things. That's sort of just something they've got to do to make it work on AWS. They really want to think about just building their Express application or building their Node HTTP server. And so one of the things we support at this in this cloud package now is the ability to create a little API. And this API just has a little factory here, which lets me create my own HTTP server using Node and return that. And we're just going to serve that using whatever cloud platform technology we have under the hood. And so in this case, I'll just say, const, let me just get Express here. Okay, and now I'm going to say const app equals Express. And now I'm going to say return app. Okay, and now we see my error squiggles went away. So what this expects is to have returned something which supports the Node HTTP server pattern, so the request response callback. And the Express is one example of something which does support that. And so I can just create a new Express app in here. And now I can say something like app.get, and for those who have used Express, this is very familiar kind of territory. I can do something like res.json, hello world. Okay, so there we go. I just created a little Express app, and now I'm going to say export const endpoints equals api.url. Okay, so this is another way to do kind of something similar we were looking at before, but where I get to use the full capabilities of Node and Express in this case. So let me know, so this previous destroy actually failed, and it failed actually in a really nice way. I'm very thankful that it does this. It says error deleting S3 bucket. The bucket you tried to delete is not empty. So that's because we did put some objects in there. And so what I can do is come in here and say AWS S3 RM, grab that bucket name, and then it's called package.json. So this will actually delete that thing. And now I believe if we Pulumi up-y, we should continue the deletion of those remaining resources and now stand up all of the stuff that we need. But one additional thing here, it's telling me I actually need a new configuration setting. So right here it tells me that I need to set the cloud provider. And so here I'm going to set the cloud provider to AWS. And the key thing here is that this cloud package, as I mentioned, is neutral to the different clouds. And so I can use it on any different cloud. And so here I need to tell it that I want to target AWS and create resources inside AWS. So let me go ahead and say Pulumi up-y. So we'll see it's going to create all these new resources, and then it's going to clean up the old ones that were there from before. So it's going to go ahead and create some similar code to what we saw before, but now we see it's doing that to create this cloud HTTP server. We'll give it a second to deploy that function. Okay, and now it's cleaning up after itself. Okay, great. And so now if we hit this endpoint, we should see hello world. So just like we expected, we're now serving that API using AWS. So another pattern for doing this. But of course, the key reason we moved over to using this, well, there's two. One is that we get to kind of use the full Express, and we could take an existing Express application, just run it right inside here. Really flexible in terms of running sort of node code here. But the other reason is that this cloud package is cloud neutral. And so we can also do something like, say, Pulumi Stack init serverless Azure. And so I'm going to create another stack using the same program. In this stack, to run this, I'm going to have to do Pulumi install --save at Pulumi Cloud Azure. And for this stack, I'm going to need to, well, I'm just going to try and run it and see what happens. So in this new stack, I'm going to stand this up, and I'm just going to say Pulumi up. So the first thing it says is because in this new stack I haven't provided that configuration, I need to tell it which cloud in this stack do I want to target. And instead of me saying AWS here, I'm just going to say Azure. And now if I run Pulumi up, it's going to try and deploy all this stuff using Azure, but that means it's going to mean we need to set some additional settings. So for example, it's asking me to set the Azure location, and so I'll just say US West. If I do Pulumi up one more time, we should actually try and deploy. Oh, I'm not logged in right now, so let's log into Azure. And we'll go ahead and do Pulumi up. So the key thing here is I'm taking that exact same application that I just wrote, no changes to my application code, and I'm deploying it just with a change of a couple of config variables. I'm going to deploy it into Azure. And so we see here we're creating the same cloud HTTP server, but because of that configuration, we're actually going and creating resources in Azure instead of in... I got US West wrong. Okay, I'm getting my clouds confused. It's West US. Okay, let's try that again. So one of the nice things you see there is even when things like that fail, like I got the name of that thing wrong, which is sort of a typical mistake as you're kind of developing these applications. One nice thing is that it did actually succeed in creating several of the resources that did not depend on that. And so you'll see that there's no change to those, and we're just able to continue going from where we got to. And so every time there's sort of one of these failures in Pulumi, we make as much progress as we can, we hit that failure, and then we kind of can keep going towards the new desired state that we want to deploy to. And so here we see we create a bunch of these objects to support that. We create a storage container to upload the source code into and a zip blob for it. And now we're actually creating that function app inside Azure to run our function that's going to handle this HTTP API. And so all of this is sort of beneath the hood stuff that you can use, but the key thing here is that using the same very simple front end to this, I can run and deploy a serverless application to either of these platforms. Okay, so there we go. Now we've got this thing running on Azure. Might take a second to warm up this first time, but there we go. We're serving it off of Azure website/API, that exact same API there. And of course, the benefit of this is that as well as me just serving an HTTP server, I can also do things like say, let bucket equals new AWS or new cloud.bucket. So I can create a bucket in a cloud neutral way. I can also create a new table, so I can get, if I want to have some table storage, I can do that. And so so this will now go and create either my cloud storage in Azure Cloud Storage or my DynamoDB table. And over time, we're going to add more things here. So we're thinking about kind of adding the ability to have a MySQL store that's implemented in the various different ways that managed MySQL is supported on the different cloud providers, or adding managed Redis in the various different ways that that's supported. So it's really easy to take advantage of these building block components of the cloud without taking a hard dependency on any one of the particular cloud platforms. Okay, so that's a quick kind of overview of some of those pieces. One of the things I want to kind of do before I finish up here is just show, point us to a couple of other examples that build on top of this that you might be interested in sort of taking a look at to go a little bit further. So one that's kind of interesting here that builds on top of what I just showed is Cloud.js HTTP server. And so in this example, we can see a slightly richer version of the same thing we just showed, where we have an out HTTP server that creates an Express app. But in this case, we handle all routes and then just write some code to count how many times that route has been hit and to store that in a cloud.table. And so this has a backing data store associated with it, and it manages the state of those routes for you. But again, this can be deployed to any cloud